Okay, here we are back with the next proof of concept for our Memory Master game. This time around, what we're going to take a look at is creating a sequence generator. The idea is to create this random sequence that continues to grow and grow and grow. And the best way to show you what we're talking about, Logan, go ahead and execute the final result of what we're about to build.
Okay.
And so right now our arrows are going to begin flashing. By the way, our graphics are based off of Stepmania, if anyone happens to play that game. Logan's a big fan of it and has made some tweaks to our code, which we might be showing you a little bit later. So if you want to make a DDR-style game, you can quite quickly with all of this good stuff. But anyways, so he's used the arrows for the time being, since the idea is just to show you how to go about generating a sequence that continues to grow as long as the player is able to match that sequence when it's the player's turn to input it.
Right, so what has just happened is with those three lights that you saw three of the arrows light up and then go dark. That was a sequence that it is waiting for us to input.
Right.
And now it has entered a waiting state where it's wanting us to input that sequence.
Again, this is just a proof of concept, so the code is it's loosely written. There are some things in there that this time around we have purposefully coded in such a way it's very simplistic and very easy to see, but it is definitely not efficient whatsoever. So think about some of the ways that some of the things can be defined, can be stored. Think about how much memory you're using. Not that this game is overly complex in memory usage and all, but we've set it up so that there's definitely some things for you to think about in this.
Right. For some of the subsystems, we took the quick and dirty approach and putting them together. Some things can be made to make more sense, can be made to be more readable.
That's right.
But the idea of this was to have a proof of concept seeing a auto sequence generator working. So just keep that in mind. Some things that are number-based could be enhanced to be made more readable. Some things are number-based for a reason. So keep all that in mind as you watch what everything's doing.
Exactly. And now, of course, the idea is for you to draw inspiration from this example and draw inspiration from the last example. And then we're going to get into sound as well so that you can mix some sound into this, but you put it all together, and then you start to have the required knowledge to put together the Memory Master game. So, Logan, I don't know if you saw what the sequence was.
I have no clues. I'm going to hit right, which will probably fail.
Okay.
Now, after I failed the sequence, what it's going to do is going to simply repeat that exact same sequence. So it was actually down, left, up. So if we hit down, then left, then up, then those keys light up as we press them, and we've successfully repeated the pattern. If we continue now, it's going to start with that pattern but add 1. So now that was, what was it, down, up?
No.
Down, left, up, left. So down, left, up, left. That succeeds.
All right, so keep playing through for a minute. So down, left, up, left, left.
Down, left, up, left, left, right. So down, left, up, left, left, right.
And one more time.
So down, left, up, up.
Nope.
No, up, left,
down,
left,
up, left, left, right, left.
But there's
so there you go. So you have a little Simon Says type game right here, ready to go. Simple success or fail. But the idea is that by the end of this video, you have general knowledge on how to put together a sequence generator like this that continues to grow in response to a user properly inputting the sequence in, the previous sequence. So that is what we're looking at creating. And with that, Logan, let's go ahead and close this out. I don't think there's anything we need to look at in regards to code here. We're just going to build all of this outright. So let's go ahead and jump over to a clean Visual Studio Express. Very nice. And let's go ahead and start with our Windows game project.
All right, I'm going to make a new project, a new Windows game, and I'm going to call this game Sequence Test. So we'll hit OK. We've got our new project, and I'm going to begin by adding a textures folder, because of course we need the graphics for those directional arrows. So I'll make a new folder called Textures. And now I need to get those graphic files copied over. So here we have our working folder that has 4 arrows for up, down, left, and right. And here we have our projects folder with the newly created sequence test folder. Inside of that we'll find textures, and that's where we'll dump all of our graphics. Now we can go back to Visual Studio and add those to the textures folder. So that would be under Content Pipeline Files. We have arrow, down, left, right, and up. We'll add those in. Now, before I leave the textures folder, I also want to import a font, because you saw the text on screen for describing success or failure. We need to have a font so we can draw those words. And I'm going to add that to the textures as well. We're not categorizing fonts differently at this time, and they do store texture-like information. So I'm going to add our font to the textures folder. So we'll make a new item, a new sprite font, and I'm going to call this large font. Now, large font, we want to be based off of the Tahoma font, and we want the size to be 30, point size, and the spacing is fine. We want the style to be bold. And we can save our font, and that'll all get taken care of when we build. So we've got textures loaded, we've got the font put in. Now we should probably go and put our classes in.
Okay.
With the class files themselves added. So I'm going to add a new folder called classes. And to that folder I'm going to add 2 new items. We're going to add a button class.
Am I looking at a sprite font?
Oh, well, good catch. I was indeed about to create a sprite font instead of a class.
Okay.
So yeah, good eye on that. And the classes are going to be button, kind of like how we had in the bouncing object example, except this button class is going to do something entirely different. We aren't merging the worlds yet.
That's right, which means for those of you that are putting this together, think about that. Think about how the button would need to take on the actions that we had. Yeah, the characteristics of the last button class, and of course the characteristics we're about to demonstrate in this example with this button class.
Right. So let's get that added in, and I'm going to add one more class as well. I'll go ahead and get the class itself added just so we can follow standard procedure and skeleton everything in. I'm going to add a new class, and this time I'm going to make a class called Input Helper. Now, what we're going to use Input Helper for is, this will be more clear when we get to the input section, but the basic idea here is that input in XNA just allows you to get the state of a key or a button. It doesn't give any functionality for has a button just been pressed or just been released. And since we want these inputs to be put in one at a time, meaning once you press the up key, that's it. You don't want to accidentally press the up key 60 times if you happen to hold it for a second.
Right.
So what Input Helper is going to do is it'll make a nice place for us to put code that will allow us to detect key presses.
Okay.
So we've got our button class, our Input Helper class.
That's the 2 classes that we're going to use. So do you want to go ahead and start out with the main game itself and go ahead and just implement all of our basic stuff?
Right, we could go to the main game class. We could put in all of our fields. We could also skeleton in all of the extra methods that are going to be put into game 1.
And then, of course, we can just go ahead and skeleton in button and input helper as well after we do that. Sounds good.
Right. So, beginning with game, let's swap back to...
Jump back over here to page 1
of our game class.
Okay.
And we need to put some fields down for the sprite batch that we're going to put in. And we will, of course, also need a sprite font because we're drawing text. And I'm going to drop in a random because random is going to be the basis for our random sequence. So let's drop these in. Let's put down a sprite batch called sprite batch. We'll put down a sprite font called sprite font. And we'll put down a random object called random. Now let's see, what else are we going to need? These are some basics, just getting some drawing and text abilities. Now we also want to have state set up for this game, because you saw before there was a state for showing the user what the sequence was. There was a state for getting input from the user. There was a state for showing failure and a state for showing success. So before we get too much further, I want to put down a game state field, but I need to define what the states are. So I'm actually going to jump up above the game class and define a game state enum. So we'll say enum game state. And let's have 4 different states. I'm going to call these input, output, succeed, and fail. So here is input, output, succeed, and fail. So with this enumeration defined, we can go back to the game class, and we can define a game state field, and we can call game state. Now let's see, what else would be useful? Well, the buttons that we've defined are going to represent those directional arrows, and we need to have a way of holding 4 of them on screen. So in order to hold the buttons that we have available, I'm going to make a button array. Since we have the button class defined, we can make a button CS. I bet the sub namespace is still there. So let's very quickly go into button and game or input helper and remove the class's sub namespace.
Okay.
Upon doing that, we should be able to define a button array, which we'll call buttons.
Which I'd like to point out real quick. The nice thing about this entire proof of concept is, as in this section we learned about arrays and we learned about structs, we're going to be using both in this particular simple proof of concept app.
Right, so that'll be cool. So we're going to have an array that holds our directions, our buttons. Now, when we get into dealing with the sequence itself, we need some way of storing what are the correct directions. The sequence is going to be some number of items long and going to have to hold some form of data that points at different directions. Now, the simplest way I can think of doing that would be to make a list of numbers. If we make a list of numbers, well, we have an array set up here, and if we have 4 buttons, we're going to have elements 0, 1, 2, and 3. Mm-hmm. So if we have a list of numbers, we could have maybe the number 1, followed by the number 2, followed by the number 0, followed by the number 3, and then if we lit those up one by one, those would each represent different directions. So in order to store the sequence itself, we're going to use a list of byte. Byte being the most convenient small number to store things in. We only have 4 directions. We don't think we're going to go for 256 anytime soon, so we'll use byte. That should give us plenty of range. So we'll make a list of byte that we'll call sequence. Let's see. And yeah, that one's just sequence. Now, once the player goes to input a sequence, we need to remember what the player has input so that we can compare that to the actual generated sequence. So I'll make a second list of byte that I'm going to call player sequence. Like so, and I believe that had an E on it. Sequence like so. All right. Now, one more thing we'll need is we need some way of remembering when it's in output mode, when the game is showing the sequence itself. As it goes direction by direction, it needs to remember where it was at, meaning where it was at in the display sequence. So what we need to do is to remember that. I'll store that in an int for sequence index. And I'm trying to remember why that wasn't a byte. I think it has to do with some of the loops that we use. At some point we could try turning it into a byte and see if that induces any type of necessary casting. If it does necessitate the need to casting, we could leave it int, which is probably why it's int right now. Now there's a few other things I want to set up. You saw when the game was running that as the arrows would flash, there was a specified interval between each automatically generated flash. There was also an amount of time that each of those buttons stayed lit before they went dark again. And I'm going to term the action of becoming lit and then going dark, we'll term that action a pulse. So saying that the button pulses means that it becomes bright for an amount of time and then goes dark again. So what I want to do is make some values to set up how the pulse should be defined, how long it should last and stay on, and also how much time should elapse between individual pulses. So I'm going to throw down a couple of double fields. These being double just because being timing based, that means I can directly use the values from the game time itself without having to cast. So I'll make a double for pulse duration. This being the amount of time that a button will stay lit after it's been told to pulse. Now we'll set that equal to 0.2. And we'll make another double field. This one called time interval. This will be the amount of time between individual pulses. So we'll call this time interval. And we'll set that to 0.5. And then one more value to put down, and that is, since we don't have any external timing code, we need to have the engine remember, as it's counting down between an interval, how much time is left until this interval has elapsed. So basically we start out with the interval being a full half a second, and then as time progresses we should chip away at some value, and then when we run out of that value, then we know it's time to execute a pulse. So I'm going to throw a double field down called time remaining. Right, and like so. And we won't give it a value. Instead, we'll initialize it and then reset it as we run out of interval times.
Okay.
So I believe that should be all of the fields. Yeah. Just checking the spelling on that. For some reason, that looked weird, but it looks like it's all.
That's because you got an extra G in there.
Remaining. There we go.
There we go.
Remaining.
So yeah, it did definitely look weird.
All right. Now there's a few more things to throw into the skeleton of the game class, and that is some methods that we're going to have in order for the game class to be able to process things like sequences and button presses. So let me define some methods that we'll just skeleton in and we'll get back to later. These are going to be append sequence, press button, and check sequence. And I believe that's going to be all for the, well, I guess what we could term utility methods. So the first is going to be append sequence, private void append sequence. And we'll take in an integer for how many things to append. So we'll take in a count. Now what append sequence is going to do is, you saw as the game was running, every time we successfully completed a sequence, it made that sequence one longer. So as though it was appending a new random number to the end of the sequence. And in giving ourselves the count, that means when we initially set up the list, we could tell it to append sequence and give it maybe 3 numbers. And that way we'd have it starting at 3 instead of having to call append sequence 3 times. So that gives the option of appending more than just one value to the sequence.
Okay.
Next we have the, we'll have a private void pulse. And we'll take in an integer for an index. Now what pulse is going to do is to take one of the buttons based on index and tell it to pulse, as well as play any associated effect that is to go with pulse.
Meaning some sound if we want it.
Right, if we were to add sound, we'll have this all happen in one central location. And the reason to have it as a central separate method is so that you can have the same piece of code called for when the computer initiates a pulse in the demo sequence, and for when the player initiates a pulse when they press a key. And after that, we'll have a private void for press button. Private void press button. And this is going to take in a byte for button index. And really, to link these up, I might actually change pulse to be the same thing, because these are going to refer to the same thing. Press button should interact with the button. Pulse will interact with the button. So I'm going to change both of them to be button index and be based as a byte.
Sure.
And let's see. Now press button is going to be used by the player. It'll be used to handle when an incoming key happens. And the reason that needs to be different is when press button happens, we need to do some other things, like check the sequence to see if that button being pressed actually broke the sequence. And that leads us to our last method, which is the check sequence method. So check sequence, and its job will be to go through the sequence list, go through the player list, and see if all of the numbers stored in each match. Because if any mismatch is found, then we need to switch over to the failure state. Unless the sequences match in length and are all correct, then we can go to the success state. And I think that takes care of the skeleton for the main game class. Let me build and make sure that there's no errors induced. There's only warnings for all of the fields that we're not using. So that's good. Now, while we're skeletoning things, we could move on to the button and the input helper classes and skeleton those as well, so that should we need any of the methods from them, they'll be available. So let's take a look at the button class. Inside of button, we can probably do away with the system collections and text namespaces, though we should probably add on framework and graphics, so we have access to textures and colors. So I'll put down a using for Microsoft, and suddenly I can't spell, .xna.framework, and also framework.graphics. Now for the button class itself, we need 2 fields and a few methods, or actually 3 fields and some methods. We'll have 2 public fields and 1 private field. Now with those public fields, those could be properties if you wanted, but again, this is a more quick example of how this can be put together. So if you want to wrap these into properties for your own use, then that might actually be a good idea. But for these fields, we'll have a public texture 2D called texture, so we can store a texture for this specific button. And we'll also have a public color to store the current color. As a matter of fact, and yeah, I am going to make that public. Really, this would make more sense to be a read-only property, but I'll just throw that out there because public will in fact make it accessible. The reason we need to have this color available is it needs to be used in the rendering code. So let's see, we have the color, and now we need one other thing. Now the button itself is what's going to be responsible for changing its own color. That means when we tell the button to pulse, it's responsible for becoming bright, and then after an amount of time elapses, going back dark again. That way we don't have to worry about additional timing code in the main code, especially since that timing code could be tricky, because many buttons could be hit in quick succession with arbitrary offsets depending on how the user hit the button. So we don't want to have to set up some big time management system in the main code when each individual button could be told to manage its own pulse color state.
Right.
So what I'm going to do is add in a private field, a double called time remaining. Wow, remaining is just killing me tonight. And we'll use that to allow the button to count down how much time should be left before it should go dark again. Now let's skeleton in a few things. Let's make a public constructor, a pulse method, and an update method for the button. Let's have a public constructor. And even though we're skeletoning in, I could go ahead and just drop this one in. The only thing we're doing in the public constructor is to initialize the color, because of course it's going to start out black and invisible, and we want the color to default to gray. Let me change the casing on this field. So the color starts out at gray, and that's how we have that kind of half-lit look. What we'll do is we'll swap to a color of white to give the brighter look. Now the next method we'll have is pulse. This will be a public void method called pulse. And pulse is going to take in the duration that this button should remain on, because back in the main game is where we have the actual setting for how long buttons stay on.
Right.
The individual buttons don't really care. They can be told to stay on for however long you want. That also means we don't have to store any extra data inside of each individual button. So we'll take in a double called time remaining, or really, this might make sense to do pulse duration, because pulse duration came in from the other way. So pulse for duration. So we'll do this. Pulse for a given duration.
Okay.
That way, we'll leave the skeleton of this blank until we get to individual implementation.
Okay.
So, one last thing to drop into our button class, and that is the update method. So this will be a public void update. And update is going to take in a game time, because it needs to know how much time has elapsed, and therefore how much time to take away from that time remaining field.
Right.
So that takes care of the skeleton for the button class, and let me build really quick to make sure that that's all working very nicely.
So far so good.
And yep, everything's looking good there. So now we can skeleton in the input helper class. So once again, I want to take away collections and text, and let's drop in input, or framework, and framework.input. So that is using for Microsoft.xna.framework and framework.input. There we go. Now, in the input class, this class's purpose is going to be to remember more information about keys than XNA does by default. That is, I want to remember for a specified set of keys, not only if it is up or down, but also if it has just been pressed or just been released. So inside of the input helper, we're actually going to add a few things. We'll have the input helper class itself, but we'll also have a struct that describes our new enhanced keys. I'm going to call this game key. So before we even get into the input helper itself, let's make our game key struct. So make a struct called game key. And game key is going to have a few fields. It's going to have a public keys variable called key. Now this is, of course, the XNA input, so you can have things like keys.up, down, left, right, enter, A, B, and so on.
Mm-hmm.
So the game key is almost like an enhancement to the key. As a matter of fact, it holds reference to a key. Now it's also going to hold some more information that will be helpful to us. We're going to have a public bool for whether or not the key is down. We'll have a public bool for has the key just been pressed, and a public bool for has the key just been released. Now I'm also going to make a public constructor, or make a constructor for this struct, so that whenever you make a game key, you can immediately associate it with a specific key, since you would need to have it associated to a key to be useful. So I'll make a public constructor, and this constructor will take in a type of key. So we'll take in an input.keys type, which we'll call key. Now, of course, it's our responsibility to initialize the struct inside of this constructor. So I'll set this dot key equal to the given key. We'll set this dot down to false. This dot pressed to false, and this dot released to false. And that will make up our game key struct. Now, inside of the input helper class, what we want to have first is a few fields, and the main field being an array of game keys. Basically, what keys does this input helper manage? So I'll make a public static array of game key. So game key, open closing bracket, and we'll call this game keys. And before I get too much farther, let me also define this as a static class, because we're only going to have one input helper, and it would be more convenient to not have to manage the creation and initialization of the input helper. Well, we may do a little bit of initialization, but it makes it easier to access if we don't have to have a reference. Now, two other things that we want to hold as fields inside of input helper are two keyboard states, what we could call a current keyboard state and a last keyboard state. And it's having these two different states which will allow us to detect when a key has just been pressed or just been released. So we're going to make some private static fields called, and these will be keyboard state fields. One called keyboard state, and another, which I'll just copy and paste the line, for last keyboard state. And that should be all of the fields we need. Now we need a static constructor and an update method for the input helper. So static input helper, and all we do here is set up the game keys array. So game keys will be equal to a new game key array, and I'll set up all of the elements that we need to have in here. As a matter of fact, I'm almost thinking of leaving this blank for the moment and getting back to the initialization later, because this will be relevant to the keys that we actually use for the input, and there's a reason that I define a certain order of these.
Okay.
So I'm going to leave it as a 0-element array, and we'll get back to the actual keys that we use when we implement everything. Now we need a public static void update method. And we'll just leave the contents a skeleton. And also note that I'm not taking in the game time, because at the moment the input system doesn't have to know about time, it just has to know about keys that have been pressed.
Right. All right, so do you want to, at this point, before we wrap up all the skeletoning, do you want to go ahead and get the sprite batch and all that set up?
Right, now that we've got the basic skeleton set up, we could start to put some of the meat in. That is the initialization of things like the sprite batch, maybe load some textures in, stuff like that.
And the fonts, yeah.
So let's go back to the game class, go up to the very top, and let's see, all the way down to initialize.
Yeah. Go ahead and create our random. And
so let's see, if we want to start with a random, we could do random, of course, equal to a new random. We could look at the sprite batch. The sprite batch is equal to a new sprite batch for the graphics device. Graphics.device, not hash code. And let's see. We could set up the lists. We have those sequence lists. As a matter of fact, we also have the buttons.
True.
We have the button type, so I mean, we could go through a few things that need to be set up. Next, we could look at the buttons array. So we could say that buttons are equal to a new button array, and I'll define all of the elements here. And each of these elements are just going to be a call to each button's constructor. So new button, and then so on and so forth. I'll actually copy that part and throw each of these buttons down on a new line, so that we have 4 buttons, since each button is going to represent a direction. Drop those back a few, kill the last comma, and end off the array. Alright, next we could set up the sequence lists. So we could take our sequence reference and set that to a new list of byte. We could also set up the player sequence and set that equal to a new list of byte. And let's see. While we're going through here, I'm trying to think of how much of the functionality we want to put in, because we need, once the sequence is set up, both of those are going to be empty, and we need it to have it start out with 3 items in the list. So, I mean, we could make the call, since we've skeletoned in append sequence, we could call that with a count of 3.
So it goes ahead and initializes 3 different things in the sequence.
Right.
Sure.
And let's see. We could initialize the time remaining value.
Okay.
And set that to time interval. So that means when the game starts, we actually have to wait a first half a second before we go on and actually start doing things. Otherwise, the first button would immediately light up.
Right.
And let's see. We could set our starting game state to be game state.output, so that the game is demoing a sequence to you. And that's actually has
all of initialized
rounded out nicely.
Cool.
Next, we could look at loading in all of our content, our graphics for the arrows and the font. So we could go down to the Load Graphics Content section, and we could look at loading in the textures. Now, we don't have any texture references in the game itself. The only texture references that exist are in the buttons themselves. So we could use those buttons. So we could say buttons sub0 dot texture is equal to, and then we'll load in our texture. So content dot load. We'll load in texture 2D for the textures, and let's take in textures, and then let's see, this is going to be the first one. The way these arrows are set up is button 0 is going to be the left direction, button 1 is going to be the up direction, so it basically goes left, up, down, right. So this is going to be arrow left. And then we can copy that line and paste it a few times. And let's see, so we've got left, we've got up, down, and right. And that takes care of the 4 textures. Now we can load in the sprite font. So we can say, what was it, large font, or did I define that as sprite font? I think in the fields I might have defined the field as sprite font, and I meant to call it large font. So we can go back up to here, change this to large font to more or less match the name that we dropped into the textures folder. So scrolling back down to load graphics content, we'll say large font equals content.load, a sprite font. And we'll load in the resource textures and then large font. Alright, that has all the necessary content loaded in. So what we could do now is turn our attention to drawing. Since we have the buttons array defined, we have the necessary textures loaded into them, we could set up a loop that would draw all of those buttons to the screen.
Okay.
So let's jump down to the draw method. First we'll change the background to black, just to match the demo app, and then we can start addressing the sprite batch. Of course, beginning with a call to spritebatch.begin. And we'll go ahead and drop in a call to spritebatch.end. And we'll use a for loop to set up the drawing for all of the buttons. So let's see, we could do something like for I is equal to, or I continues until less than buttons.length. And then we can access all of the individual buttons. So we could do a spritebatch.draw call for each button. And we'll draw using the current buttons texture, so buttons I.texture. We'll draw at I'll make a new vector 2. Though to make this a little bit more readable at the lower resolution for the recording, we could make a position vector 2 outside of the call sprite batch and make it a little bit easier to see what's going on. So we can make a vector 2 called position and set that to be a new vector 2. And now we want the X component, since these buttons start in the upper left-hand corner of the screen and progress to the right. We can have the X component be set to I times the width of the button, so I times 64. And then for Y, they're all across the top, so they could be 0. And that should make a good auto-positioning value. So we specify drawing for the texture, put in position, and for the color, we'll use the current buttons color. So buttons I.color. And that should finish off the draw call. Now, if everything's working, everything loads correctly, we should be able to build and run. We have our 4 directions drawn to the screen.
Very cool.
Now we can turn our attention to the sequencer.
Exactly. And to be honest with you, Logan, I think this is a great point to wrap up this video. We'll just break it up into a part 1 and a part 2.
Sounds like a really good idea because we've got a lot to find. We've got a bunch of skeletoning in, we've got fields, all the way up to the basic draw. So we've actually got some of the stuff starting to be laid in.
Exactly. So, all right. So that's going to wrap up part 1, and in the next part, we'll get the sequencing in place and everything functioning.